Also known as the God particle, the Higgs boson is a subatomic particle in the Higgs field that theoretically gives mass to atoms. The Higgs boson is even smaller than the individual components of a single atom: protons, neutrons, and electrons. The Higgs boson is the central piece that holds together the Standard Model, which is a theory that explains what the world and the universe is and what holds it together.
In 1964, Peter Higgs and Francois Eglet proposed the idea of the Higgs boson. After they came up with the Brout-Eglert-Higgs mechanism, this mechanism gives a mass to the W and Z boson when they interact with an invisible field, now called the Higgs field. The Higgs boson is a visible manifestation of the Higgs field. In 1994, people of the field of particle physics made the decision to begin building the Large Hadron Collider, the LHC, a machine that would allow them to theoretically find the Higgs boson particle as well as other new particles that they'd never seen before. After 20 total years of building and maintenance on the LHC, they were finally able to do a test run on September 10, 2008. The test run proved successful. However, 9 days later, a leak of liquid helium caused many of the magnets in the LHC to burst, which would put the experiment on pause for over 1 year, so that the LHC could be repaired and that it could be ensured that such an incident could not happen again. After years of experimental improvement, by the end of 2011, the data production rate of the LHC was 4 million higher than its first run in 2010, when they first began collecting data. On July 4, 2012, at the ICHEP conference in Melbourne, the ATLAS and CMS experiments observed a new particle in the mass region around 125 to 126 GeV, which is in between the GeV values for supersymmetry and multiverse theory, which are 115 GeV and 140 GeV respectively.
The Higgs boson can be used in conjunction with the Standard Model to allow it to fit gravity into its model, which is one thing it hadn't been able to do before the boson. As it stands now, all the matter that we can see appears to be no more than 4% of the total. The Higgs particle could be the key to opening the door to understanding the other 96% of the universe that remains obscure. Future and more precise testings and experiments on the Higgs boson and its GeV value will continue in the year 2015, with the LHC running at full capacity. This testing will be able to tell us whether the GeV value of the Higgs boson corresponds more to supersymmetry or to the multiverse theory.
If the GeV value of the Higgs boson turns out to be closer to 140, that means that the multiverse theory is supported. If this happened, all of the work on particle physics corresponding to supersymmetry theory would be irrelevant. If the GeV value of the Higgs boson turns out to be closer to 115, that means that the supersymmetry theory is supported. If this happened, the field of particle physics corresponding to supersymmetry theory will expand as the theories of most particle physicists will be confirmed. This would be a huge step forward for particle physicists and the field of particle physics as a whole. As of today, the GeV value of the Higgs boson remains at a steady 125 GeV until further experiments are done on the particle.
On December 10, 2013, the Nobel Prize in Physics was awarded to Peter Higgs and Francois Englert for their work on the Higgs boson.